Well, thanks for your attention today. My name's Dave Johnson. I'm coming from Duke University, where I'm a professor of the practice there. It's a little bit different than a standard professor position, where my job allows me to take things like new technologies into practice and develop them. And so I got invited to come and talk a little bit about some of the conservation things that you guys might be interested in. And so I'm going to talk specifically about drones and marine science and conservation. But I think a lot of the things that I'm going to talk about are applicable to terrestrial and many other kinds of conservation. So to start off, I want to kind of get you sort of situated on how I think drones fit into what I do and where they're taking us. And so there's three real important components to keep in mind. One is that they're providing us something that we've never had before, and that's on-demand remote sensing. Okay, so we've done a lot of remote sensing from space. And it's great, and drones will not replace that, but they do allow us to do things in an experimental way that allow us to take advantage of particular situations. They also allow us to do things that are brand new. New types of methods bring new observations that are pushing us forward in our knowledge about how things work in the environment. And as other people have pointed out, they're cheaper, they're safer, and they provide us better data in some cases. So keep those things in mind when I walk through the case studies that I want to show you guys now, okay? So first of all, this is a little bit of video that illustrates what it's like after Hurricane Matthew in North Carolina, where we're having an overwash of a barrier island. And this barrier island is essentially the last sort of barrier between us and the open ocean. And what you're seeing is waves propagating across the top of this island and actually pushing rafts of sand off the surface and into the sound. So open ocean on that side, sound side here. And this is literally how barrier islands migrate. So you guys are getting to actually see that process, something that takes a long time. And you can see that it's happening all across the length of that. The video is going to speed up a little bit now, and it's going to kind of rotate around the end of this island where you can see that some of the vegetation is inundated. And it's going to spin back around, and it's going to then move to a three-dimensional model of that particular habitat that we developed from data during the low tide surveys. So here's a 3D model, thanks Pix4D. And this model actually has accuracy of around 2 centimeters horizontally and less than 4 centimeters vertically. Okay, and so we actually went through this process and actually tested it with traditional methods using laser line scan instruments to be able to actually determine that. So this allows us to actually take advantage of things like storms. So a hurricane is coming, we go out, we make measurements beforehand. The storm comes through. As soon as it's gone, we can get back out and make those measurements. And these are the kind of results that we can pull from that. And so here's a couple of maps that show that barrier island mapped out from a drone. And there's 3 lines on there. There's a blue line, which is the baseline, and that's for the 0.25 meter isoline. So that's essentially a quarter of a meter above a standard model. And then you'll see an orange line, which is right after that disturbance. And you can see that that 0.25 isoline was pushed 35 meters inland after the storm. So we were really worried that this was a huge insult on this island. However, when we went back 2 months later to survey it again, we got to see that the island has recovered from that. Okay, so now when we look at the green line, which is recovery, we see that the island has, in fact, migrated inland from the storm, but not 35 meters, only about 5 meters after things get back to normal. And this is allowing us now to be able to take advantage of these storms, to be able to understand how our coastal environments are changing. And this is pretty important for anyone who lives on a barrier island, right, to be able to understand how this occurs. So, second one I want to talk about is about how we can use these in novel environments. So this is me actually launching a SenseFly EV in Antarctica. If you notice there's a little penguin there, he stopped to take a look. Off it goes. After the launch, I'm going to take you guys now to Avian Island. This is a place, a penguin colony below the below the Antarctic Circle that has several areas of penguin colonies. These are Adelie penguins. And this is a model that's created through photogrammetry from the 2D photos that we took over the island. You'll see there's a lot of some snow still, and we're going to come over and actually stop over a penguin colony where you can actually see individual penguins, and then we move on. Okay? So this is allowing us to be able to get to an island very quickly, launch a drone, map that island, and then be able to go and count those animals. It also allows us to be able to look at the three-dimensional habitat relationships between them. So if you notice, the penguins tend to be up a little bit above the water level and above the background. It turns out there's some magical elevation and distance from shore and slope that makes them safe from predators, things like leopard seals that might want to crawl out and eat them, that we can now actually go and understand. So when we get those data back and we map them out, we can actually have students, mostly, go and count them. And so one of our undergraduate students, Clara Bird, actually went through the island and counted 60,205 penguins. And she also created a thermal algorithm that allowed her to do that. That took her 4 days, nonstop. But then she created a thermal algorithm that does it in 20 minutes. I'll talk a little bit more about that in a minute. So a really amazing use case. Now I want to take you to not mapping, but to think about individual animals. And so this is an example of us working in the Antarctic trying to study humpback whales and try to understand their behavior and understand their body condition. I apologize, you guys get to look up my nose here for a second. I do trim those hairs. We launched the drone from this small aircraft, and you'll see it take off, and if you're observant in the background, you'll actually see a whale there on the right-hand side just making a dive. And so we use these aircraft to be able to fly over and actually study their behavior. The drone's going to pan down now, and it's actually going to give you an image of what's referred to as bubble net feeding. So for the very first time, we're able to actually study how these animals create nets in the ocean to be able to corral prey and feed on it. So here you see on the right-hand side, you can see a series of bubbles that are being produced that go around in a circle. Here's another one. And the whales will come up in the middle of that and eat the krill that are being corralled. Here's a really great picture, a set of a video that actually shows what that looks like close to the surface. So you can see those bubbles coming up to the surface. And there's one whale coming up after taking a huge gulp at depth. Another one will come up beside it, and then they'll move on to the next patch. These are incredible tool use cases, right? These animals are creating nets to be able to corral that prey. And that's what it looks like from the surface, right? That incredible circle. We're also really interested in understanding their body condition. It turns out we can do photogrammetry on individual animals. So as the camera pans down, you can actually see a pair of whales there, right? And using our sensor, we're able to actually take high-resolution pictures. The payload that we have on that particular drone has a high-resolution still camera, a thermal camera, a video camera, and a laser altimeter. And that laser altimeter allows us to be able to accurately scale each individual photo, and then to be able to take it into a semi-automated system where we can actually measure the length of the whale and the width of the whale, and for the very first time, without having to kill them, to measure their body condition and how healthy they are. Right? So an incredible way to be able to use this technology for good. And when you look at, say, the difference between a mom and a calf humpback whale from the data that we collected this year in the Antarctic, you can see that when we look at along their length, from 0 to about 90% of their length, they differ by about, well, in some cases, almost 85 centimeters, close to a meter in terms of their girth. And that's what you would expect, right, for a baby whale to be able to grow up into a mom. We can go now and take pictures of these animals through the season and measure how they gain weight, how they're feeding, and understand how healthy they are simply by flying over them, not even without them even knowing, to be able to take a photo of them and measure their body condition. All right. Next. So another use case is counting seals. So this is a little gray seal. And we use the SenseFly EB to actually count these animals in places like Canada. So this is a quick sort of breakdown on how we would do that flight planning. We set up a region of interest. Here's the aircraft flying over that. It's taking pictures. Here's some pictures of those individual seals in various places. A little bit of video that will actually just take you by that seal colony to see what it looks like. These spots on the snow that you see here are actually evidence of birth. So this is right around when those seal pups are born. And that's the primary focus of this project, to be able to go out there and actually count the number of seal pups that are born to be able to estimate their population. This equipment is fantastic for us because it allows us to get to an island, create a flight plan in minutes, launch it, recover it, and get out of there. So people who are have really tight time windows It's really, really useful for that. And probably not the best place to leave it, right, James? No. It worked out okay. And so when we think about what that looks like, we take all those photos and we stitch them together. In each one of these dark spots that you see along here, these are adult seals. And this is mapped at 2.5 centimeters on the ground resolution, right? So we're able to identify seal pups and adults. It takes a lot of time. And like that first picture that I showed you, those animals are white, right? The pups are born white on snow, which makes it much more difficult for analysts to find them. And they also tend to crawl up under some of these trees and things like that, which makes it hard for the analysts to detect. However, we can use a thermal camera, and they can't hide from that, right? So here's that same area flown with a thermal mission, and you can actually see the individual animals and their pups. And this makes it much easier for analysts to detect all the seals that are there, as well as the seal pups, which are a little bit smaller and often white and hard to detect. The other thing that's really great about this kind of imagery is that it lends itself to some computer vision techniques. So our analysts, it takes them days to be able to go through and count all these seals. And it turns out, if myself and someone else in the room counts the same set of pictures, we're going to come up with different numbers, because we all perceive the world a different way. However, our computer vision techniques can help us eliminate that because they do the same thing every time. And so we actually just published a paper using this imagery to be able to develop an automated system that actually takes us now from having to spend 2 weeks counting photos to being able to do it in 20 minutes. And so this paper is published open access, and that workflow, which goes in, is built right for ArcGIS. You guys can go and download it and use it on your own, or adapt it for your own projects as well. So a really good example of how we can take that technology to the computer vision space and really speed up how we do our work in the environment. So yeah, that's it for me. I just wanted to put in a plug for some ideas that we have for Flying Labs. We're starting a project, I think, down in the Dominican Republic, which I think there's someone here who's been there, and I'd love to talk to you more about that, working with folks and thinking about things like manatees and mangroves and those types of things. And then the other Flying Lab that I'd be interested in working with We Robotics on is one working with First Nations people in Canada. So we're working with a group there that has the legal right now to manage their own fisheries, and they're looking for novel ways to be able to collect data and understand how they can manage their fisheries using geotechnology. So it's one of the other things I'd like to try and push forward with the people while I'm here. So thank you, and happy to take any questions.